Hi everyone. Welcome once again. I would like to, before we begin today's class, right, I would like to discuss about um, DevOps, DevSecOps, cloud engineering, and SRE. The main reason why I want to treat this topic at the very beginning of your career is for you to understand their definitions, their roles, the tools, and the key differences between these three titles, right? In some companies, they are being used interchangeably. Sometimes there's a thin line between DevOps and cloud engineering. There's a thin line between SRE and DevSecOps, right? There's a thin line between DevOps and DevSecOps. There's a thin line between cloud engineering and DevOps, right? So the reason why I want to share this with you at the beginning of your career is for you to have that foundational knowledge, understand what is their difference, and be able to know when to use them. There's one other one I missed out, platform engineering. Yeah, I would like to also add that one also too. I'm going to update this document. I also like to talk about platform engineering. I'm going to talk about it also too. Even though I didn't add it to this document, I'll add it later on. We'll also talk about platform engineering. What are these things? What do they mean? When do I say I'm doing cloud engineering? How do I know I'm into DevOps? When do I say I'm an SRE person? When do I say I'm a DevSecOps person? You understand? Understand the tools they use and everything. Okay, so let's start with DevOps. Everyone in this journey, we are all looking forward to become a solid DevOps engineer, right? But what is DevOps itself? We have done that in the onboarding. You watch some few courses, but I want to give you some unique definitions, right? So I wrote down here that DevOps engineering as a portmanteau of development and operations. It suggests a cultural and technical approach. Note the word cultural and technical approach. DevOps engineering is the role, is the title, but DevOps itself, as I always say, it's a culture, it's a concept. They suggest a cultural and technical approach to software development and IT operations. What is it trying to suggest? What is a problem DevOps is trying to solve? It's trying to break down the silos between development and IT teams. What that means is that the development guys, which are the developers, the guy that which when I say developers, it includes the back end developers and the front end developers. They work in a separate office. If let me give you a diagram representation of that. Let me do a whiteboard here to show you what the silo mean. Let me do a whiteboard here. Okay. Um, I'm going to do a whiteboard. Okay. I'm going to give everyone access later on to the whiteboard. So I want to kind of give that idea of what that silo is, right? So let's look at this. Let me take a pen. See this as the what? As the developers, right? They are the developers. They are the guys, the back end and the front end. These are the guys that write the code. They are the one that built the application. They built the application to make it functional. Then we have the IT guys, the IT and the operation teams, right? Mostly we call them operation teams. Sometimes they call them the sysadmins, the system administrators. These are the guys that manage the infrastructure. When I mean infrastructure, the servers, the mainframes, right? The virtual machines that is going to make this guy be alive, right? But these guys don't work together. They are not on the same team. They don't collaborate. When the system administrators or the ops guys are buying their virtual machines, they don't talk to developers. They don't ask the developers, oh, how many memory do you think your application is going to need? Right? Oh, how frequently would you be deploying? They don't talk to them. They just go and do their things. The developers also too, they don't talk to the system admin. They don't talk to operators that, hey, how does your machine look like? Is this a Windows or is this a Linux? Or are you using Dell? Are you using this thing? So the developer might be using Windows and the servers that the guys using are actually Linux. So there's a wall, a big wall between these guys. So the developers in his own Windows machine or Linux or whatever, even if it is Linux, it could be Ubuntu, and this guy can be running on Kali Linux or CentOS or Red Hat, right? So it builds the guy on his machine, it deploys it, and then without even proper communication, it just throws the code over to the guy with set of instructions that says, hey, this is application, do this, do that, this, that, to install it. And the system admin like, okay, it takes this thing, after some days, he tries to install it, and the application is not working. The system admin guy will just delete it and say, hey, take your code, it is not working. The developer will be like, it is working on my system. Why is it not working in your system? And there's a lot of back and forth. Before you know, the company is supposed to go live in January. It will take them, they'll go live in October or November because of the back and forth. So there is no proper collaboration between the ops guys and developers. And that is what DevOps is trying to solve. So it's trying to break down the silos between development and IT teams. It emphasizes on collaboration, automation, and continuous delivery. Emphasizing on continuous delivery, the ops guys, the IT guys, they don't like you just disturbing their servers, sending code all the time. They want a stable infrastructure. They are not concerned with what you're writing. They just want a stable infrastructure because they don't like breaking changes. For instance, now this guy is using Python 3, right? And he was like, oh, there's Python 9.8. I like Python 9.8 because of the features. The guy just changed his code, changed the 9.8. Meanwhile, on this operation guys, on the virtual machine, the minimum version that is there is Python 2, right? And before you know, it breaks the deployment that the users are that the production users are consuming. They're like, oh no, this is breaking changes and stuff like that. And for the system admins to upgrade the virtual machine to Python 9.6 will cost him some other things also too. So like, no, I don't want this, I don't want that. So there's a lot of back and forth between those two things. So what DevOps tries to do, right, is to bring collaboration between these two teams, right? To emphasize automation. That means that the developers does not have to throw the code over. There should be a pipeline that will link these two guys together. A pipeline that will allow free flow of deployment, right, between the developers and the ops guys. In the which when we talk about the ops guys, we talk about about the machines, what they manage, right, without breaking down the environment, right. So to ensure collaboration, automation, and continuous delivery. So this pipeline needs to ensure that these guys can continue to push their code through that pipeline without breaking the system and the admin guys' virtual machines or environment. So that is what this DevOps is trying to do, to create this line, this pipe here that allows free flow of good communication, flow of deployment, and also to what is the last one? Continuous delivery. Okay, so this pipeline to ensure all those things. So that is what DevOps does. So you need to now let us look at their roles and responsibilities. DevOps engineers works as catalysts for change in organizations, fostering a culture of collaboration. They implement and manage CI/CD pipeline. So as a DevOps engineer, you need to work with this mindset. As you're starting your career, you need to work with this mindset. You need to have this residing inside you, embedded inside you that, okay, I'm a catalyst of change. In some organization, in some JD or requirement I've seen, the first thing they ask is good communication skills. Can you communicate? I'm going to tell you the reason why you need to communicate. Last week, yesterday, Friday, not even last week. So a developer called me and say, hey, my application is not working. I'm calling a particular part /XY and it's returning 404. I was like, that means that the part is not working in your code. So if I don't have good communication, so I will have say, I don't know what is wrong, and maybe even insult the person. She was like, oh, the part is in our code and stuff like that. I said 404 means that I'm trying to call an endpoint in your application that is running, but it says not found. It means that application is not running. Okay, let's go to your code. What is in your code? She's showing me the part is there. Then I sense that builder, she has made the changes, but the application has not been rebuilt for that change to take effect. I said, okay, rebuild your application, right? She rebuild the application. And for me, I have designed a pipeline already using GitOps such that once she rebuild her application, I don't need to do anything. Our applications deploy automatically without me doing anything. So I've set up that pipeline, please. So I start on the call with her. she made the change and then it deployed and then it worked. So good communication is important, and we had good rapport, right? So that's why good communication is what is important. You can't be everybody's enemy in the team, right? So and apart from with alongside the good communication, you also need to be able to collaborate. Also, to as a DevOps engineer, you implement and manage CI/CD pipelines, automate repetitive tasks, and ensure code quality. At every point in time, I am putting checks into the pipeline to ensure that the guys are writing good codes. You need to help the developers write good codes, else they'll just write what they like and then they'll push it. But you need to put checks in your pipeline, things like unit test, linting, formatting, right? Using tools like SonarQube, which you will see in this your journey, right? To ensure that they'll have quality codes, because if your code is not quality enough, when these guys, these wicked hacker guys, black hat guys, once they download your code and they do reverse engineering and they find a lot of vulnerabilities in your code, they can reverse engineer and manipulate your users, and then they're going to be in a big mess. So ensure quality code, automate repetitive tasks. I have a lot of bash scripts to do different things. When I see that I'm doing this thing more than 2 times, the next thing I'm writing a bash script using shell, which I'm going to do in Linux administration, and I'm doing that immediately. DevOps engineers are responsible for configuring, managing, and optimize tools that enhance the software development life cycles, right? Tools like GitHub Actions, which are for CI/CD, any tools that the developers are using, you're responsible for configuring and managing it. They focus on building the bridge between development and operations to accelerate deployment cycles and reduce deployment errors. I'll give you an example of my workspace also too. What we have done in the DevOps teams is that we ensure that, especially in the dev environment, they can build their image by themselves. They can build their image by themselves. And once they build their image by themselves, we already have a pipeline, a setup that automatically deploys their image without we doing anything. It builds their image. We have a containerized environment. It takes our image and it deploys it for us. So we have set up that process. We are even working on a process right now in our own workspace, such that developers can even write their own pipelines by themselves by just clicking some things, and they begin to write their own pipeline. So as DevOps engineers, you begin to think about how to make this process easier and smooth so they can deploy without even calling you, right? You don't have to be on the call with the developers all the time. So that is what those are the roles and responsibilities. There are many more, but basically at the core, these are your responsibilities. At the core, these are your responsibilities. Key technologies and tools. What are the tools that we use? What are the technologies that we look at? Version control system, which is Git, right, for source code management. Um, we have Git, we have GitHub, we have GitLab, we have GitLab, we have Azure repos, we have code commits, different tools out there. Okay, then CI/CD tools like Jenkins, Travis CI, Sako CI, GitHub Actions, GitLab CI, a lot of them outside here. Configuration management like Ansible, Puppet, and stuff like that. Containerizations. Um, Also, in that configuration management, you can also include things like Terraform for infrastructure as code, containerization and orchestration tool, Docker and Kubernetes. We also have things like Containerd, a lot of um, containerization to outside there, monitoring and logging also to Prometheus and for Prometheus, ELK stack and stuff like that. So, what are the goals? Faster development life cycles. So these are your goals in the team as a DevOps engineer. Faster development life cycles, to promote quicker development and release of software, collaboration, automation, and error reduction. These are your goals. In a company where you find yourself as a DevOps engineer, you must ensure that these things are achieved. They must notice that, oh, when you joined our team, there were faster development life cycles, collaboration has increased, we have automated every process, and we don't spend hours resolving problems in production, not even in UAT, you know. So I think that is that about DevOps, right? Key tech, okay, the other one I would like to talk today is cloud engineering. Okay, so if you notice right here now, we didn't really discuss much about um design architecture, right? So what is cloud engineering? It involves the design, implementation, and management of cloud-based infrastructure and services. It harnesses cloud computing platforms to host and run applications, database, and storage solutions. Now, at the introduction of cloud, right, then we need to have what we call cloud engineering. Initially, what we have are data centers. Companies goes, I want everyone to take this assignment, watch videos on data centers. What does it look like? So company just build a nice big warehouse. Imagine a big warehouse and you now build, let me see if I can even show you a picture of a data center. Let me see if you can see a picture of Google data center, right? Let's just see. Let's go to images, right? You can see what data centers are like, right? So you can see what data centers are like big machines, right? See what data centers are like. These are servers. This is what make Facebook to work. The WhatsApp you are using is running on something like this. The WhatsApp you are using, the Facebook you are using, the TikTok, for those that do TikTok, for those that go to Twitter, for those that do Snapchat, these are the things that are all your photos that you have uploaded on Facebook, all your videos you have uploaded on TikTok, they are stored in something like this. Look at the cooling system. These are the things that make the guy cool because that place is always hot. Servers are always hot. So if you don't have proper cooling system, bro, you're in debt. You don't have proper cooling system, like proper cooling system. You can go and watch this video. It's a very nice video. I've watched it before. I don't know. Say this fans not eligible for this thing. I'm just going to grab the link and put it in the chat. Inside Google Data Center, everyone can grab it and watch it later. It's a very nice. Very nice video. Let me see if I can grab the link. Copy link address. Yeah, you can watch that video. So this is what data center looks like. So before cloud came in, so companies have to build their own data center by themselves, then set it up, and then they can say, oh, we need for now. Let's buy one server, right? And then as their users are growing, they begin to buy more servers. They begin to buy. Facebook are buying more servers. Google are buying more servers because users are growing every day, so they need to buy more servers. So because the number of users are increasing every day, AWS and GCP, I don't want to exaggerate, but they might be buying servers every day because people are increasing every day. People are going to the cloud, so they need to buy more machines to increase their capacity to allow more users to come in. For instance, now you build one room for you and yourself. You now give birth to 10 children. One room cannot serve all of you now. You need to build more rooms, right? Then your 10 children now give birth to five each. Of course, 10 rooms cannot serve all of you again. You need more rooms. So that is what servers looks like, right? So you need to buy more servers to accommodate more people. But it is expensive and difficult to set up. That's just true. For you need experience, like you need experts that have been in the field for a good number of years to do the setup. Look at an engineer trying to, fix something, or maybe you click the like button and it's not working, and they have to come there and fix one or two things like that. You can see she's drinking coffee. Some of them even use skateboard to walk about. I think I was in Google data center, some of them use skateboard to walk around as big as it is. So what am I trying to? I'm trying to draft the cloud engineering. Now, because to set up data center it can be very expensive and difficult to set up. Now, there's now what we call something cloud. What is cloud? Cloud is actually data center also too, in a physical place somewhere, right? Not that it's in the heaven. It's a physical place like this also too. So what we are trying to do is that what cloud means is that, okay, don't bother about the setup, the cooling, the security, the physical security, the setting up and everything. Don't bother about that. I'm going to bother about it for you. Like me, I'll build the data center and do all the things for you. You just come. I'll give you an interface. You just come and select what you need and grow at any point in time. That's what cloud is. So AWS, for example, they have a large data center. Maybe we can even see, maybe there's a picture for it. AWS data center. Maybe there's even a picture for it. Maybe let's see. So you can see, look at their data center here. Look at that big. So they buy a lot of servers and they give us an interface that we now use to control the server. So on that interface, we go and say, I want two VMs, which is like a virtual machine. That's why I call it virtual machine, because you're creating it virtually, right? So I want 10 EBS, which is like a volume, like a Yamaha hard disk and stuff like that. Without you actually having a data center, you have access to infrastructure. That is why it's called cloud. Do you get? I'm trying to drive to a point. So you don't have to go and buy a big warehouse. You can see, apart from the fact that you're going to spend money on servers, you're going to spend money on infrastructure. Like look at buildings. Look at buildings. These are erected on hectares, not even acres now, hectares of land. Like you need good number of lands. Look at this one. Look at how big it is, and stuff like that. So this is a data center. So you're going to need a lot of money to set up your infrastructure. So we don't have to go through all this stress anymore. That's where cloud comes in. Now, because there is not cloud, we need an engineer. What is an engineer in a basic sense? Are people that bring solutions, right? So we need an expert that can help us harness the power of the cloud. That is where cloud engineering comes in. So it involves the design, implementation, and management of cloud-based infrastructure and services. When you say cloud-based, it means that you're not managing your own data center. You are doing everything from the cloud. That means you are leveraging on another cloud data centers to build your own infrastructure as a plug. You don't have to reinvent the wheel. However, I've been able to establish that point. So we need a cloud engineer that knows how to design, like, okay, I need a database because these cloud centers are in different regions. You need to be able to design that, okay, I'm going to need 5 servers, and if need be, how do I auto scale that 5 servers to 10 servers? Okay, I will need this database in this region, in this availability zone. So a lot of designs, right? And we have to make sure that their design is resilient. That means it must be available at every point in time. It doesn't make sense when an application is not available, right? When they are designing, they must make sure that okay, it is available. There's a between resilience and availability. They must also ensure that we discuss that. It will also ensure that it is scalable, right? Because why build an infrastructure that is not scalable? For instance, now the data centers, it is for them to scale. When you tell them scale, what that means is that they'll buy more servers like this, they'll buy another unit. That is what is called scaling for them. But in the cloud, what scaling means that you renting more servers, not buying. Okay. So cloud computing platform. So it's harnesses cloud computing platforms to host and run applications, databases, and storage solutions. Okay. What are their roles and responsibilities? Cloud engineers, architects, scalable, reliable, and cost-effective solution. When it says scalable, ability for you to expand on demand. That's what we call scalable, right? For instance, now let's assume that AWS build a warehouse that can only take 10 machines. So by the time they need to bring in 50 more, there's no more room. That means that infrastructure is not what? It's not scalable. Do you understand? Then they'll have to go and look for another way to do that. So your infrastructure must be scalable. It must be able to expand when needed, and it must be able to shrink when it's not needed anymore. For instance, now look at Jumia. During December, a lot of people we shrunk into Jumia. At that point in time, Jumia must be able to expand because a lot of users are coming in. And then after December sales period, by February, when people are already broke, Jumia afterwards, because of cost, Jumia was able to shrink back that okay, people are no more using these servers. Let me shrink back to save cost. That's what cost will be. Reliable. Doing this thing, during peak period. If your site is not reliable, it means that your site is not accessible. It's not accessible. And once your site is not accessible, it is not reliable. Cost effective must be that you must ensure that you're not wasting money. You're not creating resources that you are not using. You're not over creating resources, and you're not under creating resources. And to ensure that, for instance, in a place where you're supposed to use a virtual machine of, let's say, T2 medium, you're not using T2 large. You're wasting money. So cloud engineers ensure all these things. They manage cloud resources, ensuring optimal usage, security, and compliance. Don't forget that AWS only give you physical security. Security is a shared responsibility in the cloud. Security is a shared responsibility. You must also have security in mind using things like firewall, Amazon Guard Duty, ACLs to protect your own infrastructure. while Amazon also is also providing its own security in its own aspect. So you don't leave the security to the cloud. Don't say because maybe the other that's giving infrastructure. No, you also have to be secured in the cloud by yourself. Cost optimization is crucial, ensuring that cloud resources are used efficiently. Data migration to the cloud alongside with hybrid cloud setup may also fall under their responsibilities. So for instance, some companies are like, hey, I don't want to do this data centers anymore. I want to move into the cloud. I want to move all my families to the cloud. I want to move all my resources to the cloud. So a cloud engineer must be able to design a data migration process or roadmap, right? You can't just shut down your data center. You must be able to move your users without impacting your users. You must be able to move your data, right? And some companies like, for instance, some government does not run all their resources in the cloud. They have their own data center. For instance, you cannot ask the Nigerian government to run all some sensitive information in the cloud because of data policies, right? So some data must not leave Nigeria, some data must not leave South Africa. So you cannot say, and for instance, and I'm not sure AWS or Azure, I'm not really sure they might already have large data centers in Nigeria, yeah, right? So for some security reasons, some top companies like government, military, some top hospitals, generally in the health sector and the finance sector, don't like to store all their data in the cloud for security reasons. So they still want to keep their own data center, they still want to run their own infrastructure. So you as a cloud engineer must be able to design right those things and ensure that you can work both on-prem. So they call that kind of thing on-prem and in the cloud. What are your key technologies as a cloud engineer? Cloud services like Amazon Web Services, which is provided by AWS, Microsoft, which is Azure Cloud Platform, which is provided by Microsoft, Google Cloud Platform, which is provided by GCP. We have things like we have others too, like Alibaba, Digital Oceans, Linode. What is that again? I think those are the ones I can remember right now. So you want to learn tools like infrastructure as code also to Terraform, like Terraform, AWS Cloud Formation for defining cloud resources as code, right? You want to learn containers and orchestration also to Docker and Kubernetes. So you can see that there are some tools that DevOps guys are using that these guys too are using also too. They must be able to use tools like CloudWatch, Azure Monitor, Google Cloud Monitor, and New Relic. They must be able to monitor their infrastructure also too, one way or the other. So you can see that thin line, right? Go scalable infrastructure, create cloud infrastructure that can scale with growth of applications, high availability, cost efficiency. I've explained all this earlier on, and then security and compliance. Yeah. So on security and compliance. So I've explained all this earlier on. Okay. Um the next one is sorry, I'm just gonna see for that. So the next one I'm going to talk about is SRA. And I think that will be last. Okay, we still have DevSecOps. I want to move faster. I'll just talk about platform engineering briefly. I'll add it to the list later on. Um, Site reliability engineers. Site reliability engineers is a discipline developed by Google that applies software engineering practices to operations to create high reliable software systems. Now, let's look at the keyword reliability. When someone is reliable, for instance, now I say, okay, Michael, please, every morning help me to switch on the system, right? If Michael was not reliable, I will not trust him so much because I know that by 8 a.m. the PC is up. So when I just check the PC, it's because Michael is there all the time. That's why I can say he's reliable. You get so if you go to Facebook today, it's down. You go to Facebook tomorrow, it's up. And next tomorrow it is up. The next day it is down again. You will consider as that. And people you want serious, that's what you will say. For instance, you're trying to use GT Bank and it's not working for good 4 days. You're like, I'm people you serious, right? So that's where reliability comes in. In a very simple English, it means your site being useful and available all the time. You get there are some that is where this is where SLAs comes in, defining SLAs, service level agreement. You get there too. So site reliability engineer, their own is to ensure that the site is up at every point in time. catching issues, catching incidents before the customer get that incident. They are catching it and resolving it. So there are some alerts process. There are some monitoring and alerting that has been set in place for them to catch issues, for them to catch production problems even before the users catch it. So they are most of post production. They're not concerned about whether there is CI/CD pipeline or there is automation or whether developers and operation are communicating. They don't want to know whether they are communicating. They are just after that, the fact that let the site be up again. So once they catch issues, they go to the developers, they call the necessary stakeholders and say, hey, this thing is occurring in the development environment. Ensure you fix it. So they are chasing everybody to fix any issues, right? What are their rules? So they focus on ensuring the reliability, the availability, and the performance of the systems. For instance, there are dashboard that says, oh, once the memory of the server is up to 60%, give me an alert. So once they receive the alert, the memory of this guy is increasing to 70%, they might want to call the DevOps guy and say, what is wrong? Investigate. Why is the memory rising up? Just to ensure that the DevOps guy solve the issue. That's where performance comes in. Or for instance, they say, oh, the site is slow. They notice that the site is very, very slow and it's giving users poor experience. They want to capture the necessary stakeholders to fix the issue and ensure that the site is working perfectly. They automate operational tasks to eliminate minor toil and reduce errors. They're also in charge of incident management, monitoring, capacity planning, and disaster recovery planning are key responsibilities. So they want to, these are their key responsibilities. Monitoring, capacity planning, disaster recovery planning are also one of their key responsibilities. That for instance, now, if something should happen, how do we get our site back up under normal amount of time, right? So their recovery to time, like, okay, how many hours, how many minutes does it take us to recover? They want to ensure that all these things are in place. Incident management, once an incident happens, who am I to call? Who am I to charge? You understand? So all these things are falls under their scope, right? Collaboration with development, collaboration with development team to improve system availability in a core aspect of SRE, right? Collaboration with development teams to improve system reliability in a core aspect of what is a core aspect of SRE. They must be able to collaborate with the development teams. For instance, and notice that a feature is not working. You want to collaborate with the developer. Hey, see this thing is not working in your code. Please quickly fix it. Do an hot fix or something. Okay. What are the key technologies and tools? Monitoring and alerting, right? Tools like these are the guys that use tools mostly. These are the guys that actually use the monitoring and alerting tools very well. Prometheus, Grafana, and they also monitor the system performance, right? They tools like for incident management, tools like PagerDuty, Opsgenie, and stuff like that, right? For continuous application. Then they also use some infrastructure as code automation tools also to, but they are mostly concerned about the monitoring and what and the alerting. So what are their goals? Obviously, high reliability, reduce operational toil, and continuous improvement, error budgeting, service level objectives, service level agreement, and a culture of continuous improvement. So they are much more concerned about the health of the application when it has been deployed or after it has been deployed. Okay. And before I move to DevSecOps, right, I'll just briefly talk about platform engineering. All right. So platform engineering now, to me, as I see it as an upgrade or an extension of DevOps, right? So if we go back to DevOps, we're going to see that DevOps are just trying to make the life of a developer easier. So what platform engineering does is, um, in a very simple English, platform engineering aims to give developer full autonomy, right? What that means, for instance, now developer they're finished writing their code and they want to deploy their application. Developers does not need to go and learn Terraform. They don't need to learn Jenkins. They don't need to learn GitHub Actions. They just want to be able to deploy their code and test it for the dev environment and the UAT, right? What platform engineering does is to provide an atmosphere for them or a platform. Yes, let's use what platform where they can just say, hey, here's my code. I want it deployed with so resources. I want this. But by just clicking, I want this, I want that. I don't want to use Jenkins, I want to use GitHub Actions. Okay, deploy to AWS, EKS, use one node to deploy this. Okay, use one ABS. They're just selecting and they click submit and they wait, they sit back and take a coffee, and the application is live. It gives them the URL and everything. That's what we call platform engineering. So the developers have the full autonomy; they can build and test. So when it gives them the error, they're like, "Oh, this is not working. Okay, this is working perfectly." They can just go ahead and I'm done testing, delete, and they can delete this thing, and that is all. Or they notice that there's an error, this is not showing very well, they can go ahead, build another image, and continue testing without any hindrances from DevOps or anything. There's a pipeline that tests everything already. And the platform they are deploying to is also identical or is the same as the platform that they will deploy to in production. So without platform engineering, a lot of stress is going to reduce on DevOps, and there will be a lot of back and forth, right? So that is in a very short summary. That's what platform engineering is. So as a DevOps engineer, most DevOps engineer will want to graduate into a platform engineering also too, right? Or have that as a core skill. So right now, after all these definitions, I can say that, oh, I'm a DevOps engineer. I'm also a cloud engineer, or I'm a DevOps engineer. I also do SRE, right? And when you are saying those things, you know what you are saying. So you don't just use those words without you knowing what they mean. Okay, some people will just go to their LinkedIn page, they'll just write DevOps, they'll not write SRE, they'll not write cloud, they'll not write DevSecOps. Most of them don't even know what those things do or what those things mean. You get. So now let's fly to DevSecOps. So if you notice, if you remove sec, what are you going to have? You're going to have DevOps, right? But there's a sec in it. So DevSecOps is a practice that integrates security into the DevOps software development process. It distinct from the other discipline mentioned, DevOps, engineering cloud, and it is totally different from cloud engineering, SRE in several ways. In summary, DevSecOps is all about security in the sense that DevOps want to is promoting automation, continuous integration, continuous delivery, continuous deployment, but little attention was given to security. It is very important that what you are deploying to your code that you are deploying, that you have automated, it is quality. It is not a bad code. That is where SecOps comes in, DevSecOps. So it integrates insecurity into that pipeline. We shift the security to the left. It's not when you now get to production, you now be finding out bugs. When you say we shift left, at the beginning of the pipeline, we are catching errors, we are catching security issues, right? So in that platform engineering that I said the other time, for instance, once the developer, maybe the developer did not do unit testing or anything, right? You just want to deploy bad code. Once you select deploy, their platform engineering can be designed in such a way that tells them that, hey, your code cannot be deployed to production because of these listed issues that you need to solve, right? So even though it was deployed for them in prod, right? I mean, in dev environment, it gives them the issues that, oh, these are the bugs, these are the vulnerability issues, right? These are the code smells that we find in your application. Fix them if you want to go to prod. You get. So security is a key aspect of DevSecOps. So DevSecOps is primarily focused on integrating security practices and considerations directly into the DevOps pipeline. We don't wait for the developers to build their code, right? Before we now start testing it, we start not checking the security issues. As they are building, security checks are taking place, such that if those security checks are not met, their build is being altered. That a guy, fix your problem before you deploy this code. Again, so DevSecOps is primarily focused on integrating security practices and consideration directly to the DevOps pipeline. Security becomes an integral part of the development process, from code creation to deployment. While DevOps emphasizes collaboration between development operations, it does not inherently inherently prioritize security. Note this word, by default, DevOps is not really interested in security by default. But the security checks may be included, but they are not the essential focus. So they might just include, like if I remember when I was explaining DevOps at that time, it was just some little vulnerability checks, linting and unit tests. But there are other more enhanced security tests that needs to take place, and that is where DevSecOps comes in. Okay. Also, to timing of security, DevSecOps follows a shift left approach. When you say shift left, what does shift left mean? Let me. So this is the pipeline, right? And this is where the code, this is where developers, right, push their code. This is developer here. Let me draw myself. So this is, but I'm not a developer. Who is a developer here? Let me draw the person. Okay, nobody's a developer. So this is the developer who wants to push his code into this pipeline. So DevOps will not wait for you to get to the end of the pipeline. It starts from the left. As they're deploying your code, security checks are taking place immediately, right? I'm not going to get into the details of that. That is not the basis of this call. I'll discuss with you DevSecOps in details, but that is not the basis of this call. So as you're pushing your code, security checks are taking place already. They're already scanning your code for different things. If it fails, they throw your code right back at you. But if it pass, then it flows on, right? So that's what we call shift left, meaning that security is considered and applied early in the development process. So this approach helps identify and address security issues as soon as they arrive. And there are three levels, which are low, critical, low, medium, high, and critical. I think those are the levels that we have. So DevOps, while automating many aspects of the software development life cycles, may not include security checks in the initial stages, leaving room for vulnerabilities to be discovered later. So DevSecOps also too talks about security automation, right? So that we don't have to wait for developers to build the code. As they are building their code, we introduce security into the pipeline, right? So we have things like SAST, which is static application security testing, DAST, dynamic application security testing, container security scanning. A lot of these are happening in the pipeline, especially when you're doing containerization, right? Then security-centric rules also to organizing and implementing DevSecOps often have dedicated DevSecOps engineers, right? So in a large team, in a large company, they have dedicated engineers called DevSecOps that design this pipeline. So they're going to work closely with the DevOps teams because the DevOps teams owns the pipeline. You don't deny that fact. The DevOps team owns the pipeline. So the security guys are say, hey guys, what's up? Let's work together. These are my security designs. These are how to run them. They work with with the DevOps guys, and then so if you notice when I said in our last class that as a DevOps engineer, you have a lot of customers, the IT guy, the developers, both front end and back end, the product guys, the UX, and even the security guys are also your customer because you own the pipeline and you must be able to satisfy everybody. So you talk to them, they talk to you, and then you put their security designs into your pipeline, right? So the goal of DevSecOps is to deliver software that is not only efficient but also secure, right? It helps to identify and remediate because the DevSecOps will not just tell them that, hey, like this our pipeline idea, your pipeline has failed, right? When the pipeline fails, it doesn't just tell them pipeline failed. No, it tells them the issues and give them suggestion on how to fix it. For instance, if they are using a base image that has been deprecated, right, or that is not that's already at EOL, which is end of life support, they'll tell them, "I see this image is this, is that. Do this to fix it. Do to fix this." So they give them suggestion on how to fix their issues also too. Okay, and DevOps is just to enhance collaboration and automation, right? So DevSecOps also relies on range of security scanning tools. Sorry, this is not DevSecOps teaching, so I'm not going to that, but we can check it out. There's some tools that are outside the open source and private tools also to like OAuth dependency tracker, stuff like that. So I did a table here to give you a few differences of what you have talked about so far. I will make the document available, right, and also include platform engineering in it. And in practice, these fields are often intersect, right? That is fine. Like they often intersect each other. For instance, DevOps do SRE, some DevOps do DevSecOps also too, right? Some people even take the role of DevOps and cloud engineering together, right? Some people take DevOps and DevSecOps. For me, I I I intersect between the three of them, except for SRE, right? Do I know SRE? Yes. Can I do monitor and alerting? Yes. But do I do it actively? No. But actively every day at work, I find myself between DevOps. I do DevOps stuff, I do cloud engineering stuff, and I do DevSecOps also too. But I don't do SRE, right? So these fields often intersect. Or I believe that by the time our organization begins to grow, I cannot wear all those caps. We need dedicated people for those things, right? So in practice, these fields often intersect. An organization may adopt elements of each to build and maintain a robust, scalable, and reliable systems in both cloud and on-premise environments. So the choice of which practices to adopt depends on the organization's specific needs and goals. So they say that before the company can say, oh, we want a DevSecOps, there's something that they need and there's a goal they want to achieve. So if they say they want a DevSecOps, that means they need someone to bring in security, and what they want to achieve is not only an efficient code, but a well secured code. So you can see how those things come together. So that's going to be the end of this course. I hope that at the end, you know the differences between DevOps, their roles, and their tools, and the key differences between DevOps engineering, cloud engineering, DevSecOps, platform engineering, and site reliability engineering. So going forward, know how to use these titles, know when to use them, and be sure that it is okay for you to want to cut across. No doubt, no issues. You can cut across as you want. So I hope you had a good one. Thank you.